morning. Thank you very much for coming to this session about moving our, let's say, our architecture from a monolith to a service or microservice architecture. Maybe this is, kind of use case that you might find during your career, and I think that it's, there are several approaches. I think that the approach that I'm just going to explain to you today works pretty nice. My name is Alex Soto. I work in Red Hat. My Twitter is Alex Soto B, and my email is soto@redhat.com. I'm also the author of these 4 books. And the good news is that if you go to developers.redhat.com/ebooks, you can download it, the Quarkus cookbook and the GitOps cookbook for free. So if you are into the GitOps, or you want to learn about GitOps, or you're using Quarkus, then you can download the books for free. Then, let's start. Maybe you've got your application, it looks like this, right? It's just your application, it's a monolith application. In fact, it's not just like a monolith, right? Inside, they have some modules, right? You've got the whole application, but you've got some, the user part, maybe the shopping cart part, and so on. So you've got several small parts. And someday, let's say that 5 years ago, we started doing one thing. It's like, oh, how about breaking down my monolith? I break it down. I just take all these modules and I create a service or microservice architecture. So basically, we just break it down, split them, and connect them using the network. So it's just distributed computing as we've been doing for a long, long time. It's the same idea, just having small pieces connected using the network. And one of the important things that each of the service needs to have its own database. So you cannot have just a big database and all the services just querying that database. What we need is having each service a database. And then, of course, we've got multiple points of entry. We are not just having one endpoint. We can have several endpoints. For this reason, usually we use also a gateway. Then we're moving from this old school architecture where we've got the monolith and a database, and now we've got this new school architecture, which is like a service microservice architecture, where, it works pretty well because now we are able to deploy and release to production not every 4 months, but every 3 weeks, 3 days, or every 3 hours. And since we want to deploy it super fast, now we've got Kubernetes, right? Kubernetes, we can say that it's the de facto platform for deploying Kubernetes. Deploying Kubernetes, deploying Kubernetes. Well, it could be a thing, but it's deploying our application in Kubernetes. So you might say, oh, yeah, I've got my monolith application. I need to move to microservice architecture. That's fine. But how I can do that? There are several strategies. If it's a greenfield project, then it's super easy. Just build it. But if you've got your monolith application and you want to migrate to microservices, how can I do that? Okay, one way is just rewrite the whole application. Just you take your monolith, it doesn't matter, just going to rewrite all the application from scratch with, following the best practices, and then I put it to production. Okay, that's a way to do it, but probably you're going to fail because things are hard. It's not that easy, okay? Maybe you succeed, but then you will have another question is, what's happened with my data, my previous data? I got it, my monolith, my database, it was there. But now I need to migrate to this new application, this microservices application. I need to move all data there, okay? But it's not an easy thing because now you've got all the services split across all your mesh. So, you can do it as well, but again, probably you will fail. So a better approach will be using baby steps. So instead of migrating from A to B at once, let's do it step by step, just moving one part of the monolith to a service, then another part, and then another part, and always having a strategy that if there is a failure, you can always roll back to the previous version. So you've got like a safe net, okay? So I'm going to move this part to be as a service, but if I fail it for any reason, maybe because I get some regressions, maybe because the new database is not working as expected, I can go back really quickly. So let's do that. I've got my application, my Monolith application, and I'm just going to start with this module. This is a module of inside my Monolith application. I said, oh, it's super easy. I just extract it. I just take out from the Monolith. Then I connect the network. So now my Monolith application just do a query or request to this new service, which before it was a module, now it's a service, and it works. And yes, that's true. It works, but only works if this service is a stateless service. It has no state, no database. Then you're done. But what's happening if you've got a database? There is some data. Okay, one thing that you might not do is, I will take this new service, it's going to be connected to the database, to the big database. Because remember that with microservice architecture, each service should have its own database. So this is something that you cannot do. And then also we've got other problems. It's like, okay, no, I'm not going to do that. I'm going to create its own database, which in this case is going to be a MongoDB, because this part, now that I'm just rewriting a bit, I will improve it as well, and I will put MongoDB as a database, because it fits better for the use case. But now what's happened with the data? You've got some data in the old database, other data in the new database. You start inserting data in both databases maybe, or maybe just in the MongoDB database, but then what's happened when the new version, you need to roll back to the old version? What happened with the data that you've got in MongoDB, but it's not in the database? So they start going to have some kind of conflicts, inconsistencies. And you will say, oh, I've got a brilliant idea. It's super easy. In the Monolith, I'm going to do the insert in the both databases. And then when the owner service, for example, this new part that I extracted as a service needs to select something, they're going to do it from the MongoDB. But if it's the Monolith service or the Monolith application, it's going to take it from the old database. And since I'm doing the both inserts in the both databases, that's done. And in the same way, if the owner service needs to write something, they're going to write in both databases. So, yeah, you would say, that's super cool, right? I just need to do inserts in two places. Well, then you start getting the dual writes problem. And basically, dual writes problems are prone to inconsistencies. Because just keep this, or let's see this example. What's happening if I got this order service and it's doing two writes? One to the database, and then another write to another service or another database. This is what I explained before. What's happened if I write to the database? So I'm writing here. And then when I try to write to here, this service or this database is down. Okay? You've got some data in the old database, but you do not have that data in the new database or the new service. Yeah, okay, you can start, for example, creating, I'm going to do some kind of queue with the polling system that when the service is down, I will just put this new data there, then I will have a polling system just there, trying to figure out if the data is synchronized or not, and if it's not synchronized, then I synchronize with the new system, things like that. Yeah, it will work, but trust me, you're going to start getting crazy, knowing exactly why things are happening. So what we need is another thing, which is the change data capture pattern. Things of change data capture pattern, you do not need to worry about dual writes or thinking about these polling systems and so on. You'll see that everything is managed automatically by this pattern. Basically, the change data capture pattern capture databases changes. So when you insert something to a database, it just captures this, or when you update an entry, it captures this and sends it as an event. Typically, nowadays, this event is sent through Kafka. Of course, it could be any other messaging system, but nowadays, Kafka is the thing, right? So You insert something in a database and automatically generates an event to Kafka. And then you can have several modules there listening for this event. So for example, you can have another database. So this database may be listening, this new event and inserting the data. Or you can have another service. So this service is just there waiting until there is a new record in the topic and then react. Or maybe you have serverless, or maybe you've got Flink or like Elasticsearch on any index databases, right? You want to index data, so you react by indexing this new entry. Maybe you want to do using Kafka streams or updating distributed caches. It doesn't matter. The thing is that you're using in this way. Then you said, okay, this is change data capture pattern. That's nice. But how I implement this? Because at the end, this is the idea. And before that, let me just introduce you Kafka in case you don't know what is Kafka. Because I said that nowadays, most of the event systems are using Kafka. Basically, Kafka is a publish-subscribe system. Nothing really new in this sense. I mean, it's like the GMS queue that we have used for a long, long time. But of course, it's a bit different because it's, let's say, modern. And it was built having fault tolerance and scalability by construction. So it's super easy to just scale up, scale down a Kafka cluster. It's really resilient for downtimes of a node it's down or not, or to recover. Kafka is doing this super cool. And one of the key points of Kafka is that can process all these events in real time. So instead of sending events and then, we'll see what's happening with these events, with Kafka, in real time, you can start getting some statistics or applying some changes automatically. And this is why Kafka is working really well with change data capture, because thanks to Kafka, you can just react instantaneously to a change. And if you do not know, these concepts of Kafka, we've got a Kafka. Kafka has topics, right? Topic is like where you put the events, and then each topic has some partitions. And then we've got the producers who produce events and the consumers who consume events. You see that it's not so much complicated. Well, in fact, if you start digging out about it, you'll see that it's more complicated than this. But the global idea is super simple. Then I said, we've got Kafka. We've got the change data capture pattern. I understand, but how we implement this? And you can implement it using Debezium. Debezium is an open source project. I mean, that everything that I'm showing you here is open source. That just connects to the database and just checks the database transaction logs. Because databases, inside, it has one thing that's named transaction log. This is where they store all the information. And basically, they are using these transaction logs because if the database is just doing their stuff and then goes down, when you boot up, it needs to recover somehow. And to do this recovering, it uses a transaction log. So let's say that the transaction logs is the source of truth of the database. Then, what it does, Debezium, is just listening this transaction log, and any change that happens in that file triggers an event. Maybe it triggers an insert, an update, and a delete, a creation of a table, all this stuff. It's just captured by Debezium and sent an event. And by default, although it can be extended, Debezium sends this event to Kafka topic using the Kafka Connect technology. And it's really important to understand that it's using Kafka Connect, because Kafka Connect has all these retries things, validating that there is no duplicated, be scalable. It means that if I send an insert of the database and Kafka is down, Kafka Connect will just remember that you send something that is not in Kafka. So when Kafka broker boots up again, Kafka Connect will send the event. So all this logic that I explained before of retrying and so on, it's all covered automatically by Kafka Connect. So for this reason, we've got Devisium as a Kafka Connect. If you want to use Devisium but not Kafka, you can do it as well. Okay? There's no barrier in this sense. Okay? So if you say, yeah, but I want to use Apache Pulsar, you can do it. Or Google Q, you can use it as well. There's several posts out there that explain you how to do it. Okay? But just keep in mind that the first main goal of Devisium is working with Kafka. So, as I said, Devisium works as it's based on transaction logs. It supports snapshotting, filtering. Also, it has a web UI, and it's open source, and it's used by all these. These are some of the companies that are using Devisium. You can see that probably these companies are getting a lot of traffic, and yeah, it works. And it works with all these databases and NoSQL databases. You see that this is MySQL, Postgres, Mongo, SQL Server, DB2, Oracle. And in theory, also it should work with Cockroach because it uses the PostgreSQL driver, probably also with MariaDB. Also works, but I've not tried. And there is incubating for VTs and Cassandra. So, okay, I would say that most of the databases are supported. And maybe you said, oh, yeah, you said that the Devisium is just tapping the transaction log of the database, sending an event to Kafka topic, how this event looks like. And this event is just a JSON file. Basically, it sends you what was the previous value and what is the new value. So if it's an insert, of course, the before value is empty, and the after value is the new entry. If you've got an update, you've got the previous entry and the new entry. If you've got a delete, then you've got the before with the entry, but the after is empty. And then you also have some information about who generated this event. I mean that you can say that it says, okay, I'm using the table customers in the schema public, the database is a Postgres, okay, you get some information here. Here even, you can get the operation. You see that it says U because it's an update. If it's an insert, I think it's an I, and so on. And also the timestamp. So you have all the information of the event. When it was generated, what is the content, why happened, and so on. And then, okay, we've got Kafka. We've got change data capture. Okay, we need to use change data capture to avoid the dual write problem. We cannot use inserts in both, don't insert at the same time to the same database, use change data capture. We need an implementation, we use Devisium, we use Kafka, so on, okay. But I've not explained yet how to do this migration of one part of your monolith to a service, having data involved, and what is more important, that you can always roll back. So if this is a failure, you can always go back and nothing happens. You're not losing data, you're not losing anything. And this is exactly what a Strangler Fig Pattern is used for. It's the baby steps that you need to follow to make this migration correctly. So, basically, a Strangler Fig Pattern lets you gradually evolve from an old version into a new version, having temporary coexistence. So it means that you are not doing a big bang deployment. You're not just taking your monolith, rewrite from the scratch to a microservices, start, and let's see what's happened. No, you're just taking one part, you extract one part, you try it. When it works, you extract another part, you try it, it works, and step by step, you end up by migrating your monolith to a microservice. And basically, what the demo that we're going to see today is this one, where the original application is a Spring Boot application. It's the pet clinic. Probably most of you, if you're using a Spring Boot, knows about it, that have some modules like the owners, the pets, the beds, and so on. It has only one database. In this case, it's a MySQL. Okay, and I think it's using Java 6. Okay, super new. Hope that nobody here is using Java 6 in production, but yeah, maybe Java 8. I don't know if there's a big difference, but okay. And then what we want to do is just take the owners part of the monolith, remember that this is still a monolith, and create an external service, written in Quarkus with Java, for example, 11 or 17, and in this case, using MongoDB. So I just extract this part of the monolith into a service. I also update the database to be a MongoDB. So how can I do this thing and not failing in the process? Okay, this is the first version, okay? My monolith application. All the modules are inside the monolith with the Spring, the web browser, and the database. We're fine. Everything's working. Next thing, what we need to add, first of all, is a proxy. In this case, it's Nginx, because, well, basically, when you are in, for example, in Kubernetes, you can use Nginx as an ingress proxy. So you need a proxy to just redirect traffic from one version or to another version. It could be HA proxy, and in this case, it's Nginx. Now, when you build Nginx, you configure it that all the reads and all the writes goes to the monolith. Now, this is not really dangerous. You're just putting a new piece, but all the traffic just goes to the monolith. The monolith is not redeployed. The monolith is the monolith, but the Nginx is in the middle. The next thing that you need to do is, of course, create a Kafka topic or create a Kafka broker, then put a topic, deploy the MongoDB, and configure Debezium. So here I'm configuring Debezium, as you can see here, the logo. And basically, I'm just redirecting all the traffic again to the monolith. Okay, it's this. But when I insert something into the database, into the monolith database, using Debezium, I will capture the change, propagate it to Kafka, and then I will have another connector here, which basically will get the event from Kafka and insert or update or delete the data inside the MongoDB. So basically now I've got no service extracted yet, but I've got MySQL and MongoDB, and since I want to extract the owner's information, now MySQL and MongoDB has the same owner's information. Of course, MongoDB only have the owner's information, and the MySQL database has the owners, the beds, the pets, and so on. But what's important is that the data from MySQL and MongoDB is synchronized. When we, yeah. Yeah. The question is that, okay, what's happened with the old data that is in the MySQL? I start MongoDB, I start Debezium. What's happened with the data that was there before? That's a really good question, because basically Debezium supports one thing that is named snapshotting. Okay, snapshotting basically lets you, at the beginning, move all data automatically. It's like producing all the events at that time as if they were, happening at real time, but they are not. They are basically Debezium does a select to the table, okay, and just generate all these events. And this is important because Debezium supports a snapshotting, because sometimes if you've got a really huge amount of data, you're going to lock the database because you're just sending a lot of data there, right? So what Debezium supports is that you can do some kind of batching processing. So instead of moving all the database with all the table with all the entries at one time, you just do some chunks and you say, okay, let's put then 10, then 10 more, then 10 more, then 10 more, and so on, okay? Then this is how you will see now in the demo that it works in this way. Then, when we've got this, now we can deploy the new service, the owner service, and we connect to the MongoDB. You see, still nothing happens. I mean, we are still working with the monolith. It's just that the data is replicated to two systems. When we've got the new service deployed, so this is the owners that it was in the monolith, then we do this. Basically, I know that it's hard to see, but now when we write something, So when we want to update an owner or update a pet or delete a pet, so any write operation, it's done through the Monolith application. When I want to read, you see here, when I want to read, all the reads except the owner's one goes through the Monolith. Of course, if I want to get the list of pets, pets is not a service that I'm extracting, it's just in the Monolith. So I'm just redirecting the traffic to the Monolith. But when I want to read something from the owner, then I redirect to the new service. So at this point, all the reads goes through Monolith except the owner's one, who goes to the new service, the service that we extracted. And since we are connected, the writes that happens on the owners are propagated to the MongoDB, so the reads are completely updated. You see, what's happening if there is an error here in the new version, in this new service? We detected there is a regression. Oh, we can easily roll back. We just need to update Nginx to say, look, all reads and writes again goes to the Monolith. We are not losing data, because remember that here we are just sending the reads. It's fine. I've not lost anything. Still works. Now, when you do your tests and so on, you monitor this new service, you compare with the previous version and say, oh yes, it's working pretty well. Now maybe it's time to do one more step, and it's this one. What I'm doing here is other writes and other reads, so all the reads and writes from bets, pets, and so on are sent to the Monolith. But now, when I'm writing an owner, when I am updating an owner, when I'm creating an owner, then I'm sending to the new service. So now reads and writes of owners goes to the new service. And you might say, oh, there is some missing place here, because if I write it from here, I will write to MongoDB. But if I want to roll back to the previous version because, oh, there is an error when I do a write, I need to go back to the Monolith, then, yeah, here we are missing some data. So you need to do the reverse side. So you need to just take your data from the MongoDB, send it to Kafka using Divisium, and then Kafka just send a connect to the MySQL to update the owners table as well. Of course, at some point, when you're really confident that everything will work, then you can just remove all these connect things and remove, if you want, the MySQL owner table. That's when you can do it. When you finish this with the owners, then it's time to do it with pets, with bets, and so on. It's a long process, but it's super secure. You can always roll back without losing anything. And I said before that the de facto platform for deploying microservices is Kubernetes. How we deploy all these things in Kubernetes? Because, yeah, deploying a service is super easy, right? You do a deployment, kubectl apply, done. Well, yeah, you need to do the service. Hey, it's a database. Okay, I create a stateful set. kubectl, this is a stateful set, done. Or I use Helm. Okay, Helm, install, and works. But what's happened with Kafka? Kafka is not that easy, because there is a lot of pieces to configure. And my advice is that if you're trying to deploy Kafka into a Kubernetes cluster, use Streamzy. Streamzy is a Kubernetes operator that helps you deploying Kafka in Kubernetes. So basically, it just provides all the security things by default. It lets you configure, for example, things like the rack awareness or the configure dedicated nodes for running Kafka, so you can set something like run Kafka just in these nodes and not in these other ones, the kinds of Kubernetes service that you might want to use, like node, port, cluster, load balancer, cluster IP, and so on. And what is really important is that you manage all your Kafka cluster using YAML files. Yes, nobody loves YAML files, I know, but you can manage Kubernetes cluster, Kafka cluster with or using GitOps, because it's just YAML files. So you can just get your YAML files for creating a topic, or for configuring security, or for configuring Divisium, or Kafka Connect. So all things are done with a YAML file. So you can just start using GitOps also for doing all these operations of Kafka cluster. So let's go with a live demo of all these things that I've shown you here. This is the link, and you can you will get it at the last slide, all the links. But you can just run it on your laptop. It's just Minikube. You just need to start a Minikube cluster, and then you just follow all the instructions, and yeah, it works. So basically, we're going to see this. There are some steps that I've already done, but it's like deploy the Monolith application here, then deploy the new service, the owners, then deploy Kafka, updates the ingress, all these, configure the connectors, then also, and just for read, as I said here, and then update the ingress for the write and do the reverse. So just updating MongoDB also updates the MySQL database. So, okay, so for deploying the application, yeah, I think that you cannot see anything, but it's just a YAML file of deployments and a Kubernetes service, nothing. Then, to deploy the new service, yeah, again, nothing really interesting. It's just a deployment file, and, well, here it's a bit longer because you see that I'm deploying the MongoDB here with a job and so on. So, but it's just YAML files. But now it comes the really nice part, and is deploying Kafka. Deploying Kafka, how I deploy a Kafka cluster in Kubernetes? Well, just this small YAML file. With this just a small YAML file, I'm deploying a Kafka cluster. You can see here that it said, this is of type Kafka. So thanks to Streamzy, now I've got another kind in Kubernetes, which is Kafka. So now I can do kubectl apply of a Kafka, and I will get a Kafka cluster, or I can do kubectl get Kafka, and I will get all the Kafka clusters that I've installed in that Kubernetes cluster, or kubectl describe Kafka, and I will get information about the Kafka cluster. So you manage Kafka as it was any other Kubernetes resource. Well, you can see here that I'm explaining also here configuring the port, the replication, and so on. That's one thing. The other thing is installing Divisium. To install Divisium, I need to use another YAML file. As you can see here, it's just this YAML file, which is of type Kafka Connect. Because remember that I said that I'm using Kafka Connect as a technology, right, for updating or for getting the change from the database and sending to Kafka. I'm using Kafka Connect, so I can use the Kafka Connect type. And of course, I need to configure where is the database, which events I want to react. So I want to react or send events from all the tables or just specific tables. So this is what I'm configuring here with Kafka connector object. It's not a big YAML file. And the same for sending the event to MongoDB. So here, basically, I'm just configuring using Kafka connector, events from the MySQL to Kafka, and events from Kafka to MongoDB. This is the YAML files. And we still have a bit more. Basically, it's the ingress. Remember that I said before that when we've got this, I want to send all the reads to the old version. All the writes to the old version, all the reads to the old version, except the reads from the owners that I want to send it to the new version. And I'm doing this with ingress. This is the Nginx part, okay? So if you are not using Kubernetes, then you cannot use ingress, but if you're in Kubernetes, we can just use ingress to make these rules. Yeah, you can see here there is some kind of regular expression and said, okay, if it's the owners, then send it to the Quarkus owner service, which is the service, the new service. But here you can see, well, maybe you don't see because it's so small, but here it says if not, then just send it to the old version, okay? So basically here is some kind of ingress rules. Then, if it works, it comes the next part, which is update the ingress for using read and write. So when I want to read from an owners, I need to make it from the new service. When I want to write, also want to use the new service. And I need to configure the other way around. So remember, it's like now I'm writing to MongoDB, and I want to propagate this change to MySQL. And to do that, again, it's just a matter of configuring these Kafka connectors with all the configuration of, yeah, I want you to propagate the changes from this MongoDB collection to this MySQL table. This is what I'm doing here. And of course, update the ingress again. So now it's only the reads that goes to the new service, but also the writes. Yeah, a lot of YAML files. Sorry about that, but this is the life we are living, and bad luck. So let's see it in the demo. This is the links of the slides, and this is the code. As I said, it's here, and you can, I mean, it's free. You can share the slides with all your college, no problem. You can, fork the project, do whatever you want with the code. It's just here. Then, let's just start. Yeah, I don't know if it's going to work because, well, sometimes I forget to burn some Windows XP CDs for the demo gods. And then when this happens, demos sometimes doesn't work, but let's see. I think that you cannot, let me, yeah. Okay, this is the Monolith application. Whoops. This is the Monolith application. Everything goes to the Monolith. The reads, the writes, everything from the owners. You see that I can refresh, and I get it, all the owners. It goes to the Monolith. Now, let's just start. Just to not forget anything, and since it didn't work before. Now, I'm going to configure the Debezium to take the events from MySQL and send it to Kafka. And this is done in this YAML file. I'm going to apply it here, this. Now, I've configured to react to any insert to the MySQL and send it to Kafka. The next thing that I need to do is just take the event from Kafka and send it to MongoDB. That's the next thing that I need to do. And it's with this YAML file. Apply here. Okay. Now, the data is synchronized. So everything that I write in MySQL, it's also written in MongoDB. Next step is configure ingress. I mean, well, just in case you're wondering, what is the owner service? I already deployed, yeah, you can see that if I do kubectl get pods, you see that I've already deployed the Quarkus owner service, the Kafka cluster, and so on the MongoDB. All this is already deployed, just to have more time. Then, let's update ingress. I'm going here, I'm changing the ingress. I think that it has been updated. Now, the reads of the owners goes to the owner service, and the writes go to the monolith. And if I go here and I refresh, we got it this. Okay, we got it to the previous, to the owner service, but data is not here. Why data is not here? Let me. It's a good question. Why? There's no data to Kafka, and I create it. Yeah, and apply it in the correct order, right? Probably now it would say that they didn't change it. Oh, let me try if what is the connector? This is the, no. Oh, connector is not deployed. It just, nice, okay. Yeah, so, let me, let me delete the connectors information. Now I will, for any reason, it was there, now it's not. Who knows? So I delete the sources because I've got not Debezium there, and I'm going to apply it, which is here. This, Kafka Connect. Okay, now we need to wait a bit. You see here this pod. This pod is the pod that is managing all this stuff of moving or reacting to changes, because at the end, Debezium needs to be run somewhere, the Kafka Connect, and this is a container that is running Kafka Connect, right? So it's the one that takes the events from the MySQL, send it to Kafka, and also takes care of taking the event from Kafka and send it to to MongoDB, and so on. So basically, this container is the one who does all this job. Usually it takes a bit of time, just like 1 minute or so. Let's wait. In fact, now it's downloading. For the reason it says container creating. I've got here you can see here I've got 3 screens. This is the Kafka, so this is the Kafka topic. This is the MongoDB, so this is the collection, and this is the MySQL, which is all the data. As you can see, if I do a select, you see that it's getting all the owners in the MySQL. Let's see if finally this comes to life. It says successfully pulled. Successfully sign it. Okay, now it's running but not ready. That's another thing. Now we need to wait until it's ready. I don't know what, let me check. At what point of a time this pod just died? Well, the deployment. Yeah, things that happens. Still, let's see if it starts or not. Yeah, now, okay, perfect. Now, I'm going to configure again all these here. I configure this as well. Now, if I refresh, come on. Well, you can see here now that this is MongoDB, Kafka. Now this topic has all the data from MySQL, right? So basically when I applied these YAML files, it takes all the data that was stored in MySQL, you can see this data, and created an event with it. Now, if I go to here to the MongoDB, you can see that now the data is here. Okay, so I just take the data from MySQL to Kafka and then to this MongoDB instance. So the data is transitioning from one place to another. Now, if I go here and I refresh, finally, you can see that the owner service now has all data. Right? Before it didn't have it because I didn't apply the connectors. Now I applied the connectors, and now you see that there is the data here. So the reads are going to this Quarkus service. But what's happened with the writes? I just click here, so I want to write. I want to do an update of this, and I go to the Monolith application, which is the Spring Pet Clinic. This is thanks of the ingress. And I do a change. I'm going to change this to George Franklin to George Soto. Oh, I have got someone here in the US which is familiar. So I updated the owner. So now the write, you can see that goes to the monolith. But if I go here and I do, no, I want to go to the owners.yaml file, you see that the data has been updated. So I update it in the MySQL. You see here, MySQL. Let's go to the MySQL. It's George Soto. And if I go in the MongoDB, previously was, let me find here, it's this one, George Franklin. And now if I check MongoDB, go up again, you see that now is George Soto. So I do a change in the monolith, and Divisium takes the update, move it to Kafka, then Kafka move it to MongoDB. For this reason, all the data is synchronized. Of course, as I said, this is for the reads. The writes goes to the monolith, and then it comes the next step, and it's like, okay, now I want to make the reads and the writes done in the new service. So I just go here, not here, where is here? I just take this here. I'm going to change the ingress configuration. So now I want to set the reads and writes to the new version, to the owner's version. And now I'm going to I'm going super quick now. I'm just updating all the, that the data is updated to the monolith. Just doing this, super fast, I know. Now, I think that it's done. I can refresh. Of course, the reads still goes to the owner service, but now, if I set the writes, I'm not going to the monolith. I'm just stick to the new version. I can change this to George. Okay, bueno, that's my another name. I do update. Here, it's updated. If I go to the MongoDB, you see it's updated. And if I go to the MySQL, it's also updated. So I can maintain all the data synchronized all the time. And at any point, I can just roll back to the previous version because data is everywhere. So that's all. Sorry to, with these problems, I get it 2 minutes late, but these are the links for the slides and the code if you want to reproduce on your laptops. And thank you very much and enjoy the conference. Oh yeah, you can comment, yeah, no problem. Yeah, I'm here, so you can comment any question. Wait. What if you want to? Here, okay. Schema, if you want to change the schema, yeah, there is, you can also do it because with the Divisium, it also detects these changes of, you change it, you create a new table or you updated a table, it also detects and you can propagate and react. Yeah? Yeah, new schema new is still using a SQL database, right? Yeah, you can also use it because with the Divisium, you can implement, it comes with some filters and things to modify the event. And say, for example, this, in the old table, it was name, and in the new table, it's full name, right? So you can do this, it comes by default, but you can also implement your own strategies, right? So it supports make this thing. Of course, you need to do the mapping, but it's supported. Yeah.
How do you handle a situation where, say, you got right, and immediately you read, right? Maybe the write hasn't gone all the way through, right? So you're reading all data. How do you handle consistency in that case?
Yeah.
Maybe it's something like, I don't know, define when the write is really complete, the sync is complete.
Yeah. Yeah, in this case, yeah, what you could do is, yeah, sorry. Yeah, the question is like, what's happening if I write to the, in this case, my SQL database, then it goes to Kafka, then Kafka needs to go to MariaDB, but in the middle, before you insert into the MongoDB, you do a read. You're getting annulled data, right? Yeah, that's just one of the things that can, that can happen. If it's really critical to this, what I would suggest is that you can always use a Kafka stream for monitoring, right, and then detecting. Or you could say, okay, I'm with Kafka stream, I'm going to make the read of the service before it's right into MongoDB. Okay, so you're just like just doing a short path, right? But again, you're making things more complicated. It's possible, and it's still not always the same. What's happening if the read happened just before the Kafka stream reads and so on? So you can always get this problem. It's name it, eventual consistency, right? That's true. I mean, that there is. But as I said, you're trying to migrate from monolith to microservices in a safe way. So, I mean, for this reason, I said that before, that you start with reads. Right, reads usually, okay, what can happen is that you inserted something, then you want to read it. Yeah, it's not there, but maybe you do a retry. Oh, no, it's there, right? Because usually it's super fast. Okay, but yeah, I know that you can face this problem. But what you can be sure is that insert is in the old database, because Devision works at transaction log file. So it's there for sure. Yeah. Yeah, the thing is that you're not blocking the writing the full, because you don't have distributed transaction. Okay, because you're just transactioning in the MySQL scope. But then it goes Kafka, which is not transaction, well, it's not in the same transaction. And then what you could use, maybe, we need to check it out, but maybe Saga pattern can help you on this. Maybe it could help you, but we need to check it out. Yeah, it's another pattern for this. Yeah, it's true. I mean that you can face this if it's super critical. Then I can ask to the Devision engineers, because maybe you say, oh yes. I mean that you can maybe give me another. Now it doesn't come anything into my mind, but I can ask. Yeah. Yes. Yeah, but you will always have that time until you. I mean that you detect a change in the database, then you send an event that needs to go to the Kafka broker, and so this is time. And if the Kafka broker is in another cluster and another machine in I don't know, in the near country, then this traffic needs to go to there. So it's always there is this time there. But I will ask, because I think it's a really interesting question. Maybe they will tell me, oh yes, it's eventual consistency. Sorry, but I will ask. Yeah, if you want, you just send me a message in Twitter. Right? Say, hey, I'm the guy that, and when I know something, I can just tell you, look, they told me this, because maybe they come with another idea. No, thank you.